Welcome to Cheenta Statistics and Data Science. Today we are going to solve this problem from IIT JMMS 2022, problem number 29. The problem says that let x1, x2, x3, x4 be a random sample from a distribution with the probability mass function fx is equals to theta to the x into 1 minus theta to the 1 minus x for x is equals to 0 and 1 and 0 otherwise, where theta belongs to the open interval 0, 1 is unknown. Theta is unknown quantity. It is the unknown parameter, right? So let alpha belong to this interval 0, 1. To test the hypothesis h naught theta equals to half against h1 theta greater than half, consider the size alpha test that rejects h naught if and only if summation xi is greater than equals k alpha for some k alpha belonging to this set containing 0, 1, 2, 3, 4. Then for which one of the following values of alpha the size alpha test does not exist. That means there are four viable options are given for alpha, among which one of them is such that there does not exist size alpha test for this for any particular for that particular value of alpha. So which one of the following four options is our correct answer? So it is given that x1 through x4 follows IIT Bernoulli theta, right? Because this PMF is nothing but the PMF of a Bernoulli distribution with parameter theta, right? So x1, x2, x3, x4 follow IID Bernoulli theta, where theta belongs to this open interval 0, 1, and obviously it's unknown. So test this h naught versus h1, we reject h naught if and only if summation xi, that means the sum of the values, is greater than equals k alpha, where k alpha belongs to this set, right? Now, basically what we do is we check for each of the values of k alpha among these for these five values. There are five values in this set 0, 1, 2, 3, 4. For each of the values, we try to find out the corresponding value of alpha. So we know that alpha is the size of the test, right? So alpha is equals to probability under h naught, reject h naught, right? So probability under h naught summation xi greater than equals k alpha. Now under h naught, under the assumption of h naught, summation xi follows binomial 4 comma half, because under h naught theta is half, right? This theta is half. So each of them follow Bernoulli half. Therefore the sum obviously follows binomial with parameters 4 and half, right? So this entire summation xi follows binomial 4 and half with parameters 4 and half. Now for k alpha is equals to 0, if we set k alpha is equals to 0, let us see what happens. So probability under h naught summation xi greater than equals 0 is actually 1. Why? Because it's a binomial, right? So its probability of being greater than equals 0 is 1. So that means for alpha equals to 1, k alpha has to be 0, right? So suppose we want a size 1 test, size alpha test where alpha is 1, then k alpha of the value of k alpha equals to 0 will suffice, right? So alpha equals to 1, this test, this for alpha equals to 1, the size alpha test does exist, right? For alpha equals to 1. For k alpha equals to 1, now for setting k alpha equals to 1, it was the case of 0. Now this case for k alpha equals to 1, again probability under h naught summation xi greater than equals 1 is equals to, just finding out the probability, we already know the distribution of summation xi, right? It's binomial 4 comma half, so it turns out to be 15 by 16, this thing. That means this again is the value of alpha. That means for alpha equals to 15 by 16, if we had set alpha equals to 15 by 16, then k alpha is equals to 1 would have been the necessary value of alpha k alpha, right? 1 would have been the necessary value of k alpha for this to be a test of size 15 by 16. So again, that means this test is possible, right? This is a possible size alpha test, this one. For k alpha equals to 2, we again just check it, summation xi greater than equals to, which turns out to be 11 by 16. Therefore again, for alpha equals to 11 by 16, k alpha equals to 2 should suffice, right? For k alpha equals to 3, again we find out the probability, which turns out to be easily 5 by 16, right? So for alpha equals to 5 by 16, k alpha should be 3. Now for k alpha equals to 4, the last value of k alpha is, the probability is 1 by 16. Therefore for alpha equals to 1 by 16, k alpha is should be 4, right? So as you can see, that means for k alpha equals to, for alpha, if we had set alpha equals to 1, we would have gotten the value of k alpha to be 0. For alpha equals to 15 by 16, we would have gotten the value of k alpha to be 1, and so on. So basically, as you can see, these values of alpha are possible. 1 by 16 is possible. Why? As you can see here, this for alpha equals to 1 by 16, k alpha should be 4, right? So 1 by 16 is possible. Again, 11 by 16 and 5 by 16 are also possible, right? Because for 11 by 16, this thing, for alpha equals to 11 by 16, k alpha should be 2. And for 5 by 16, k alpha should be 3. So these all three values are possible. That means the value which is not possible is 1 by 4. That means option B is our answer. This is our answer. This value of alpha, for this value of alpha, the size alpha test does not exist. So there you have it, the solution to this problem. So do like, share and subscribe to the channel for more exciting problems. See you till next time.